An exciting project in new biomaterials at Queen's School of Mechanical and Aerospace Engineering has the potential to offer life-changing treatment for patients with spinal burst fractures. Dr. Fraser Buchannan explains the work of the Biomaterials Research Group.
The project's now been running for a couple of years, and it's aimed at a new technology for repairing what's called burst fractures of the spine. This is where perhaps in a car crash or a fall from a ladder, your spine would be crushed under compression. Some of the vertebrae may crack, and we're designing cement that can be directly injected into those cracks and will set, just like a cement, just like, say, you're building a wall with concrete, it sets naturally. And the beauty of this cement is that it's got the same chemical composition as bone, and therefore over time, as bone naturally heals, the cement will integrate with the bone and actually resorb and disappear.
The calcium phosphate material developed at Queen's has several benefits over traditional spinal repair methods, as Dr. Buchanan explains.
There's a couple of things can be used at the moment. Obviously there's metals can be used, metal pins, metal cages that go around the spine. The difficulty with those is that it's very intrusive surgery to get the metal in there, and then of course you may have to get it back out again, and that's a second operation and more discomfort for the patient. There's also a technology called vertebroplasty, which uses a polymer cement. The risk with that particular cement in the spine is that as it sets, it generates heat. It actually can get up to, maybe 70, 80 degrees centigrade, and that can actually cause tissue damage, and that's not really a problem in hip joints and knee joints, but in the spine where there's very critical nervous tissue, that could potentially be a risk. Queen's has been very dominant in the international scene in polymer research. This particular project was built on several years of building up a research group in biomaterials and bioengineering, which links very well in the multidisciplinary atmosphere of Queen's. By the end of the project, we'd hope to be at a point where we can start talking to industry, to medical device companies, and transfer that technology across to them so they can start thinking about clinical trials and eventually a release of a product based on the technology. But the ultimate aim is to get natural bone healing of the vertebra and the spine to give the patient pretty much full recovery.